All right, we're going to pick up with chapter 5. This is the review slides for the final. So you can download these again off Blackboard if you don't have them, and go through them with me, or take your own notes. It does not matter. But chapters 1 through 4 are already posted on Blackboard, so we're going to look at chapter 5. Remember, chapter 5, we learned how to balance chemical reactions, and we learned how to classify chemical reactions. So a few quick reminders on balancing is that here's a key tip. Number 1, save elements that are by themselves for last, okay? So anything that is just an element by itself, you can put a coefficient in front of it without altering any other element that may already be balanced. So that's why that's helpful. Remember diatomics. Okay, there's 7 elements that are diatomics. So we have hydrogen, and then they form a 7 on the periodic table. Hydrogen is not included in that actual physical number 7 if you look at the periodic table, but we have nitrogen, oxygen, fluorine, chlorine, bromine. This is 1, 2, 3, 4, 5, 6, and then iodine. Okay, so these are the 7 diatomics, and when you write them in a chemical reaction, you write them as a diatomic. So I've actually written them incorrectly. I need to go back and rewrite them as a diatomic to give you an appropriate, it'd be H2, okay? It'd be N2, O2, F2, Cl2, Br2, 2, and iodine 2, okay? So those halogens, oxygen, nitrogen, hydrogen. So remember that when you're writing chemical reactions or balancing them. Additionally, if a polyatomic, so rule number 2, if a polyatomic is present on both sides, treat it as a single unit. So if you have it on the product and the reactant side, you do not have to separate and balance the elements in that polyatomic individually. And the whole rule with balancing is that you need the same number and kind of elements on both sides, okay? So same number and kind of elements on both sides of the reaction. That's when you have a balanced chemical reaction. So double check yourself. There's a whole lab we did on balancing chemical reactions, so you could practice that lab, print off a fresh one if you want to. We had there's several problems in the back of chapter 5 for just balancing reactions. So that will be on the final. Classifying chemical reactions. The first way we classified is we looked at 5 what I call simple. 5 simple reactions. So I'm going to draw parentheses. Okay, there you go. 5 simple reactions. So we said synthesis. An example, we just used generic letters here, would be like reactant A plus reactant B coming together to form a compound, AB. Okay, that was the example there. Anytime where you have 2 or 3 reactants on your reactant side and you're forming 1 or 2 products, if you're going from more reactants to fewer products, that's a synthesis reaction, or we called this one combination as well. Both terms are acceptable. Okay, decomposition is just the opposite of synthesis, where we have a compound, such as AB, breaking down into more than one thing. All right? So decomposition. You could also have, well, no, that's a pretty good, straightforward example right there. So decomposition, one thing breaking down into multiple things, is a good example of decomp. So synthesis and decomposition are opposites. Single displacement, that's where, say, you have reactant AB plus you have a reactant C. Okay, so usually you have some sort of element by itself here, and it is going to take the place of either A or B. Doesn't matter which one. So if it takes the place of A, you would end up with CB plus A. It kicked out A. Or you could end up with AC plus B, okay, depending on what type of element C is. If C is in main group 1 or 2, okay, it would become a cation. So we would write it first. It would kick out A. But if C was like a halogen, like fluorine or chlorine, then it would kick out the halogen, the anion in your compound. So in that case, it would kick out B. Just depends what kind of element you have by itself. But anytime you have one thing displacing a portion of a compound, that is single displacement. Double displacement, the key here is that you have, the key way to recognize it is you usually have two ionic compounds. Okay, single displacement, you had one ionic compound. D compound, and then one, say, element. But here in double displacement, we have two ionic compounds. So that's going to be like this, A, B plus C, D. And the cations and the anions are going to switch. We know we write cations first. So the cation from the first element is going to join up with the anion from the second. So you'll get AD. The anion from the first will join up with the cation from the second. So you'll get CB. Okay? That's simply as straightforward as we can put it. That's double displacement. Combustion, we always had, I feel like combustion is very predictable. Here's why. You always have some sort of what I call a carbohydrate. You have carbon. We don't know how many, so we'll put an X there because we don't know what the subscript is. And you have hydrogen, and we'll put a subscript for the number of hydrogens in our carbohydrate. So you have a substance or a reactant that's just carbon, hydrogen only. That's our carbohydrate. Reacting with oxygen every time. You have a carbohydrate and oxygen. And every time they form the same products, CO2 and water. So if you form CO2 and water, it's a combustion reaction. All right? So that's combustion. So those were the 5, what I call simple classifications. The next 3 we talked about were more complex. And here's an example problem from the textbook that's really great to work on classifying the 3 we're about to talk about, 5.34. I recommend you go work it. But what were the 3 types of complex? Number 1, we had precipitation. Precipitation reactions, these you form one product that is a solid. Okay, so it would be, you would have an S on that product, okay? That's a dead giveaway that it's a precipitation reaction, okay? Another kind of reaction that we talked about is acid-base. Neutralization reactions. Here we said if you form water, that's a dead giveaway. Or you now know that if you transfer a hydrogen ion from the acid to the base, that you get a acid-base reaction. But for the sake of chapter 5, we said that one product will be water. Okay? But now that you know, too, all of chapter 10, if you see the transfer of a hydrogen ion, so we'll write or transfer of H plus from the acid to the base. If you track that, you know it's an acid-base reaction. Okay? Number 3, it was maybe the most complex kind. It was a redox. Oxidation reduction, okay? Is what that stands for. And remember here, all that's going on is the transfer of electrons. So remember the statement oil rig for this. We said an oil rig that, so oil, we said oxidation is the loss of electrons. All right, so oil oxidation is loss of electrons, and rig, reduction, is the gain of electrons. Okay, if you're gaining electrons, you're being reduced in your charge. If you're losing electrons, you're being oxidized and your charge is increasing. All right. Also, for precipitation